So now we have this. We have our vertex buffer data. So what we want to do is we want to, for this chunk renderer, this is going to contain its own indices buffer. Now this we don't know kind of the size of, because that depends on a lot of things. For example, what's in the actual chunk, because we're not really going to generate anything for empty blocks, and we're only going to be generating for where there is stuff. So we're just going to have a dynamically sized vector of GLU shorts, because that's what an index is. And this is going to be our index buffer data. So what we want to do is we kind of want to step through our chunk, and we want to find out what indices we have to use. So we're just going to jump over into chunk, and we're going to expose a get method so that I can get, or so that it's possible to get what is in a given block, or what block at a given x, y, and z coordinates are. So we're going to call it get. So again, we're going to be looping. This time we're going to keep it less than or equal. So what we want to do is essentially that we want to go through and we want to add the faces that correspond to this block if there is a block. So if we look up in our chunk, if we have a chunk here, we call a .get here on x, y, and z. If this is not 0 at the moment, then we need to render something. Or rather, then we need to do something with our index buffer. Ideally, we should probably, rather than do this every render, we should do it at construction time, so that we can do as little as possible during the render. We can also initialize the vertex buffer at construction time just so that it's done. Now with that done, if there is something at this, what indices do we need to get? Well, we need to render sort of the negative x face, the negative positive x face, negative positive y faces, and negative and positive z faces. So to do that, what we are going to do is that we are going to add functions to sort of add the positive, negative of the various faces, so that we can just call those instead and sort of make our life a little bit simpler, hopefully. So what we want to do is we are going to do a couple of private methods here just to help us along the way. So we're going to have one here which adds positive x face. Actually, I kind of like to keep having it called add face x positive, so it's sort of the opposite way around of what you naturally read, but that sort of makes similar methods start with the same prefix sort of. So we say what the coordinates are, and we're going to give it the vector by reference, which are the indexes or indices that we want to add to. And we're just going to worry about this thing first. So for our chunk renderer, we have this add x positive or add face x positive. So what is the index of our positive, or what are the indices that we need to use for the positive x face? So what we kind of need to do is we need to evaluate this expression again, because that's what we're going to be using. And something's kind of annoying me, but it looks... Oh, down here. That's why it's annoying me. Fair enough. No problems then. So, what we want to do, we have these wonderful little indices. So, first vertex we want to add. So, we're going to add an index here. So, we push that back onto the vector. Is that we're going to add chunk at x, y, and z to it. That's sort of the base of the x. No, that's actually the x negative. For x positive phase, we actually want to go one past this so that it will be x plus 1. We're going to be adding a lot of little zeros and ones to these, so we're just going to add it all in so that it sort of we get some symmetry in this. So then we want to add the next one along the y-axis, and finally the next one along the z-axis. So this is sort of going to be the first triangle. Then we're going to repeat these two, and then we're going to add the one that is 1 over on both z and y. So that will add the positive x face here. So if we just call add face x positive here, give it our index buffer data, and then we give it the x, y, and z coordinates that we're currently looking at. That should add the indices for that face. We're going to worry about the other faces now. We just want to try and test this out and see if we can render anything with it. So to do that, what we need to do is we need to borrow this stuff. Because what we need to do then, now we've got everything set up, is that we start by binding an array buffer, being our vertex buffer here. Then we have a vertex attribute, which is going to be sort of the interesting stuff. Where does this guy get the vertex attribute, or is that just... it takes the vertex attribute in the render function. Maybe we should do that as well. So this is sort of where we bind vertex data. Great. So we need to do that on our renderable as well. Say that our interface takes that. And then we are going to, over here, we're going to want to pass that along. There we go. Forgot to do something. So when we have a chunk, this get function does nothing, so we should mark it const. It does not change the chunk. So we're not getting to this part of it. So we get the vertex attribute in, we assign this over, we still have 4 floats. We still don't need to do any normalization. Our size is, the size of every sort of the stride between every vertex is 4 floats. And we have no offset. So we enable that vertex, and then we do the index buffer, which is our index buffer data. Now we have to get that assigned as well. So once we've done all of this, we then have a GLUint, which will be our index buffer. Clean it out while I'm here. So we do create our index buffer again. So we generate an index. We generate the buffer into our index buffer here. We bind it, and then we want to go for the index buffer data size and grab the actual data and assign that. And again, we're going to go with this is static draw. It's not going to change very much. So we bind that buffer. Then we need to draw element. So So rather than having the size of, we need to go for the index buffer data dot size because we want to draw all of it. These are going to be unsigned shorts, offset 0. So in theory, that should draw something. So we're getting a -1 somewhere. Just sort of out of the blue. I don't like -1s. -1s tend to be errors. So the interesting question is, where do I just print something without doing anything else to it? No. So at some point after this, we output a -1. That was definitely not what I wanted to do. So it kind of looks like the trick today is that I should not use control clicking because that seems to be what's messing up the capture for some reason. OBS is behaving weirdly on me today. Again today. So what about the camera? Am I... Okay, quick weird idea is that for some reason OBS is dropping every time the window title changes, which is pretty much every time I switch files, so this is going to get interesting. Not exactly every time, but relatively often. Okay, so what we are going to do, rather than hunt for it, we are going to add a couple of extra prints. So what I want to see is what is the error for that, and then after every render. So we're going to compile that. And we have an unresolved symbol. Okay, if we have an unresolved symbol, I get why nothing's working. I did not notice that a moment ago. And that's because I haven't gotten around to actually writing that get method that we used a moment ago. So chunk get. So again, we're going to calculate the index the same way. Should probably factor that into a function at some point. Just an inline one, and then we're going to look up in our blocks that index. Let's try that again. So we have a successful link. Let's try and see what happens over here. I'm getting plenty of GL errors. 1282, that sounds like an unsupported operation to me. So what is going on? So now the question is, where are we getting that? Grab. Quickly. Yeah, we're going to leave those two in, and then we're going to go into the chunk renderer here. And we're going to output on both sides of this. Quickly import IOStream. And I'm just going to say 1 and 2 so I can tell them apart and compile that. Refresh. So it's after this point. So 1A, 1B, and 1C. So when we're setting up the vertex attribute pointer, interesting. Let's just for the hell of it verify that this thing still works. So yeah, that part still works and is rendering nicely. So what is going on? So we call it with the same vertex location, and our block over here does pretty much exactly the same thing. So the hell of it, we want to compare. So yeah, the only thing is that we use the vertex buffer rather than vbuff. So what could be going wrong is if the vertex buffer isn't set up correctly so that we don't get a proper bind to it. It could also be the fact that this is not supposed to be an array buffer, but an array or an element array buffer. Don't know why it would cause an error at that point, but that is definitely wrong. Still getting the other error as well. So, and we do have an if. Oh, wait. If, let's actually generate the vertex buffer. If vertex buffer initialized is false, do all of this. And then, by the way, when we're done with all of this, we want to set vertex buffer initialized to true so that we only do it once. Though, I mean, no harm comes in doing it twice. We're going to fill it with the same data anyway. Let's try and run that. Now we're getting a problem at stage 2. Despite the fact that I've now actually managed to bind it as the correct type of buffer. So the interesting question then is, might it be getting too big or is something else wrong? This is at stage 2, so where we try to draw elements, scale triangles, index buffer data.size, scale shorts, 0. So we'll just, because over here I'm taking the size of the indices. So I notice an interesting detail here is that I'm multiplying these by sizes of the elements. I'm pretty sure I'm not doing that on the other side. No, I'm not. So rather than just being the vertex buffer, I need to multiply that by size of the GL float. And here I need to multiply it by the size of the... I'll actually... Yeah, we're just going to GL U short. Let's try that. So I'm probably indexing illegally in some sense. Probably what's going on here. Now we're getting a lot of zeros, but not a lot of stuff drawn. So why are we not really drawing anything? Will be the next interesting question. Now, what is going on here? Just for the hell of it, over in the GLES render, I want to just disable these two calls because otherwise my console is going to get completely and utterly spammed in a moment with that, and I want to pick up something relatively early because what we want to do is we want to try and print out the size of both the vertex and index buffers so that we get an idea of how big they actually are. As in, they should be greater than 0, hopefully. In case they're not, something's probably wrong. Vertex buffer data and the index buffer data. Let's try that. Refresh. So we have a lot of vertexes and a lot more than you can index with a unsigned short. So an interesting question is, can we use anything other than a GL unsigned short for GL draw elements? Gonna have to take a look at that. So GLES2. Yeah, I can use unsigned byte or unsigned short. So I guess that is an argument for using smaller chunks. So I'm happy we decided to do this. So it's going to be 16 byte or 16 block chunks instead. See what happens then. So that is definitely indexable. So we have 96 indices, which seems a little bit on the low side. So we do have some indices. So why do we only have 96? So we should have 128 blocks. No, more than that. We have 16 by 16 by 8 blocks that are assigned to something, which is, I guess, 2,048 blocks that are set to something. And we have 96 chunks rendering, which is times 8, so that's 16 blocks we're picking up and trying to render. So yeah, something's... Oh. I probably have this mistake a couple of places because I've been copy-pasting this a lot. Let's see. Yeah, also in the vertex buffer. So I'm generating really, really bogus vertex data. As in, that's not going to render anything because way too much of it is on top of each other. And for the actual chunk, where is my chunk? Yeah, it's also here. Let's give that a go. And fresh. So now we are rendering a lot of faces. This I like to see, because this is what should be happening. That's sort of the coordinate looks a little bit wrong. So this block, as far as I remember, is 2 on each side. And what I'd ideally like is that our nice big blocks here were centered at 0, 0, and I'm hitting the far clipping plane. I think we might want to adjust the far clipping plane now so that we can actually render a little bit more. So we have in our camera, it's a little bit all over the place. We set up a far clipping plane at 10. I think we're going to increase that to 128 now. Should still be enough depth buffer to manage. Just refresh. So now hopefully we can go a little bit further back. Because these look incredibly wide to me. When considering that it should only be like 16 times as wide, or actually only 8 times as wide as that cube, it looks a lot wider than that. So something might be going rather wrong here. Question is then, what? Also, because I'm not really seeing the subtraction here as well. I would have kind of hoped that they started in a different place. So this is sort of the negative point, and that is positive. Oh, the joy of having the colors. And red should be X. So yeah, we are drawing the positive X face here. Or at least that's the idea. I don't think we actually are drawing the positive X face. Doesn't really look that way. Because if we were drawing the positive X face, I would expect it to start at X equals 1, whereas the first plane here is clearly at X equals 0. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 planes. That seems odd. Are we doing something where we're only getting the positive part of it? And it's sort of stretching way, way, way too far? Do I need to do some sort of weird cast, or am I reinterpreting data wrongly? Okay, these are GL floats in the vertex buffer data. Now, strictly speaking, I'm doing lots and lots of integer math here, so that should get converted to floats. Oh, wait, I'm doing lots and lots of unsigned integer math here. That is not what I want to be doing. We are going to start by adding a float to this. Yeah, unsigned math and modulus and stuff like that. Now, it's going to be fun. Let's try that again. So this looks like I'm getting a lot more faces now. And I like the fact that I'm not getting all the top one because we're sort of cutting off the chunk at one point. And I've got 8 on the positive X side, 1 in the middle, and 7 on the negative X side. 7 on, so that is the positive X space being drawn. So that's great. So far, so good. So now we're going to add the corresponding other 5 functions. So the X negative face, and then Z and Y, or Y and Z. So for this to work, for the negative here, so now we're just going to add 0 to that. And then we're going to go for the Y faces. So what we're going to do is we're going to switch the Y and the X. So that is alternating, and then it is purely ones over here. And then this is going to be alternating, and purely zeros here. And this was the positive and negative Y face. And finally the Z faces. Here we go. And for this we're gonna switch over here so that it looks like that, and then 1, 1, 0, and this is gonna be all zeros for the Z, and this is gonna be all ones for the Z. So that should render this wonderful little subchunk or chunk here. Minecraft terminology, making 16 by 16 by 16 area is a subchunk in Minecraft. Here we just call it a chunk. Great. So that means that we should be able to add the other set of faces. Actually, this is going to be easier if we just start by switching to the negative face here and then copy pasting that. So this looks dumb, but there is a reason behind the madness, because we want to kind of optimize a little bit which faces we're going to be drawing, and by doing this we can choose which faces we want to draw. So when we get a little bit further along, we can avoid drawing faces that will never be visible. So if we refresh now and pull the camera back a little bit, we have a nice big index buffer. We should essentially just see one big cube, because that is all that there's left to see now.